Volcanoes, with their fiery eruptions, have captivated humanity for millennia. But some volcanoes lurk in silence, holding the potential for eruptions so vast they could reshape the world. These geological titans are known as supervolcanoes, capable of producing eruptions that eject more than 1,000 cubic kilometers of material. Unlike cone-shaped volcanoes, supervolcanoes often appear as vast calderas, massive depressions formed when the volcano's magma chamber collapses after an eruption. Their eruptions are categorized as VE8, the highest rating on the Volcanic Explosivity Index. For context, the eruption of Mount Vesuvius that buried Pompeii was a mere VE5. Supervolcanoes don't just devastate locally, they can trigger climatic shifts, disrupt agriculture, and cause a cascade of global effects. Supervolcanoes exist on every continent, though some are better known than others. Among the most notable is the Yellowstone caldera in the United States. The Lava Creek eruption 640,000 years ago ejected over 1,000 cubic kilometers of material, covering much of North America with volcanic ash. An eruption today would likely devastate the western U.S. with ash fall, disrupt air travel worldwide, and cause a volcanic winter, reducing global temperatures by several degrees Celsius. The Toba caldera in Indonesia is another giant, with its eruption 74,000 years ago releasing about 2,800 cubic kilometers of material. This event caused a volcanic winter, dropping global temperatures by up to 5 degrees Celsius and possibly triggering a human population bottleneck. The Taupo volcanic zone in New Zealand saw the Aruanui eruption 26,500 years ago, the largest eruption in the last 70,000 years, ejecting around 1,170 cubic kilometers of material. Its effects were felt globally, with ash spreading across much of the southern hemisphere. The Aira caldera in Japan, home to Sakurajima, one of the world's most active volcanoes, erupted 22,000 years ago, forming the current Kagoshima Bay. Smaller eruptions occur frequently, but a supereruption could release vast amounts of magma and ash, severely affecting Japan and the surrounding region. The Long Valley caldera in the United States had its largest eruption about 760,000 years ago, releasing 600 cubic kilometers of material and forming the Bishop Tuff. An eruption could devastate parts of California, with ash fall extending across North America, disrupting agriculture, infrastructure, and air travel. Campi Flegrei in Italy, located near Naples, had its last major eruption 39,000 years ago, producing 300 cubic kilometers of material and possibly influencing Neanderthal extinction. An eruption today would threaten millions of people in the densely populated region and could disrupt the Mediterranean's climate and economy. The Siberian traps in Russia, while technically not a supervolcano, are responsible for one of the most catastrophic volcanic events in history, the Permian-Triassic extinction event 252 million years ago. Massive eruptions released CO2 and methane, triggering global warming, acid rain, and ocean acidification, wiping out 90% of marine species. Laguna del Mal in Chile has shown some of the highest rates of ground uplift ever recorded, suggesting significant magma accumulation. An eruption could release vast amounts of ash, impacting South America's climate and agriculture. Supervolcanoes form over hot spots or at subduction zones, where tectonic plates collide, allowing magma to accumulate in chambers deep within the Earth. David Pyle, a volcanologist at the University of Oxford, explains, "It's the combination of high magma viscosity and gas content that makes supervolcanoes so explosive." Yellowstone is a focal point for supervolcano research, with the Yellowstone Volcano Observatory continuously monitoring the region. Researchers employ a combination of seismographs, satellite imagery, and GPS sensors to track ground deformation, which can indicate magma movement. At Toba, a team from the University of Cambridge used zircon crystals found in volcanic deposits to study magma accumulation. Dr. Clive Oppenheimer explains, "Zircons are like time capsules. They tell us how long magma sits and evolves before an eruption." Supervolcanoes don't erupt often, but when they do, the results are catastrophic, with global consequences extending far beyond ashfall. The Toba eruption offers a glimpse of these effects, potentially reducing human populations to as few as 10,000 individuals, a genetic bottleneck that shaped our evolution. Advancements in technology are improving our ability to monitor supervolcanoes, with AI analyzing seismic data for early warning signs and satellite imaging providing real-time views of ground deformation. Supervolcanoes remain a reminder of Earth's incredible power. Efforts to manage their potential will demand caution, ingenuity, and a global commitment to science.